In the previous module, we looked at how to select the right electric motor for your application. In this module, we will look at how to make sure the motor is properly installed and commissioned. This will boost the reliability of the motor, minimize breakdowns, and keep operating costs down. There are 8 important steps to follow. Making sure the motor is transported to you safely, using the correct procedures for loading and securing as outlined by the manufacturer, minimizes the risk of the motor becoming damaged in transit. Remember that transport damages are not covered by warranty, so care must be taken not to damage delicate surfaces or equipment. If the motor is going to be stored, make sure that it is stored in conditions appropriate to both the type of machine and the local environment. The correct storing conditions are mentioned in the user's manual. Particular care must be taken to ensure proper ventilation and to prevent moisture, rain, and vermin from entering the machine. If the machine is equipped with anti-condensation heaters, these should be energized. Safety is always the first priority, and before we disconnect and remove the old motor and install our new one on site, let's go through these safety steps that save lives. 1. Clearly identify the work location and do a risk assessment. 2. Disconnect and secure against reconnection. 3. Protect yourself from contact with other live parts. 4. Take special precaution when close to bare conductors. 5. Check the installation is electrically dead. 6. Carry out earthing and short-circuit testing. 7. Issue a permit to work. This is a critical step because complications introduced here will impact on the reliability of the motor in the future. The installation and erection procedures vary depending on foundation type and machine, so it is essential that work is only carried out by properly trained and qualified personnel. It is important to properly align the motor with the driven equipment, as misalignment puts stress on both, causing ongoing maintenance difficulties like vibrations, bearing and coupling damage. Alignment records should be kept for future checks and reference. Make sure that mechanical connections such as pipework do not put stress on the motor's side flanges. Also make sure that pipes and accessories don't get in the way of future maintenance actions, as the longer it takes to perform maintenance, the longer the machine is out of production, which costs money. Electrical work should always be carried out by qualified personnel and should follow the applicable safety regulations. Special care must be taken when making high-voltage connections. A typical electrical connection mistake is to exclude the pressure washer, causing the spring washer to gradually work its way into the copper and loosen the connection. Loose or poor electrical connections might cause overheating and flashovers. Proper commissioning is also an essential step. The installation, including alignment and electrical connections, will be verified. Possible issues will be spotted and rectified before they can cause damage. The final test run will help confirm that all is according to specification and that the machine is ready to go into service without risking expensive materials or causing disruption to the main processes. Following these steps correctly will mean that the motor-driven machine can be put to use without unnecessary expense or lost process time. In the next module, we will look at maintaining our motor so it has a long and productive working life.